Why is manual water sampling for turbidity often not accurate? Imagine trying to catch a moving target with a net that keeps shifting. That's what manual water sampling for turbidity can feel like. Turbidity measures how cloudy or hazy water is because of tiny particles floating around. Getting an exact reading is important because it tells us about pollution levels, water treatment needs, and overall water health. But manual sampling often doesn't give a true picture. One big reason is that when you scoop water into a container, particles can settle at the bottom or get stirred up. This means the sample you take might not match what's really in the water at that moment. If particles settle before you measure, the turbidity looks lower than it actually is. If you shake the container too much, it can temporarily make the water seem cloudier. These small disturbances can lead to inaccurate results. Another issue is that some measurement methods requiring diluting water samples that are very cloudy. When you add water to dilute the sample, it changes the original composition. This can make the turbidity reading less accurate because it no longer reflects the true level of particles in the water. The size of the sample also matters. Manual samples are usually small, so they might not capture the full range of turbidity in a water body. If turbidity varies with depth or flow, a small sample might miss those variations. This means the measurement might not truly representing the overall water quality. Timing is another factor. Turbidity can change quickly, especially after rain or sediment disturbance. Taking a sample and measuring it later means the water's turbidity could have changed in the meantime. Also, delays between collecting and testing can cause particles to settle or clump together, skewing the results. The tools used in the field are often less precise than laboratory instruments. Portable turbidity meters have smaller sample chambers and can be affected by environmental conditions like light, temperature, or handling. These factors can reduce measurement accuracy. Human error plays a role too. How the operator collects, handles, and measures the sample can vary from person to person. Small mistakes, like improper filling of the sample container or incorrect calibration of the instrument, can lead to inconsistent results. Turbidity is a key water quality parameter because it affects how light penetrates water, influences aquatic life, and indicates the presence of pollutants attached to suspended solids. Accurate readings are essential for monitoring pollution levels and ensuring safe water treatment. Using automated sensors that measure turbidity directly in the water is often better. These sensors give continuous data, avoid disturbing the sample, and reduce human mistakes. When manual sampling is needed, following strict protocols for collecting, storing, and measuring samples can help improve accuracy. In short, manual water sampling for turbidity often isn't precise because of sample disturbance, dilution effects, limited representativeness, environmental changes, equipment limits, and human errors. Relying on automated sensors or strict manual procedures helps get more reliable water quality data.